sense of who's involved. Now begins the first regular class. So as a reminder for schedule, this week's class is on project management. Every other week we have a recitation. The recitations are optional, they're not required, they supplement, but they're encouraged. And the one on January 28 is very important. I'm going to introduce version control, which is how you're going to manage content. And the recitation on the 28th is going to spend much more time on a how-to to use the site that the class is based on, run by Fiori, who supports all of the computing. So that's very strongly encouraged. It's the same time class meets, but on Mondays in the same place class meets. So project management. The homework assignment for this week, first part is work through a Git tutorial. I'll explain what that is and why. And then the second part is to build a website. And so if you go through the prior years of the class, every student builds a site. And the sites are expressive, they're interesting. It's a portfolio we use to track your progress. It's how you learn from each other. It's part of how you tell other people what you've done. And the sites are really fun. They're really expressive. And so you're going to start building your website this week in the class. And so to do that, you need to know how to build the website. You need to know how to manage content in the site. This week, like many weeks, there isn't a single right answer. There are many ways to do things, and I'll cover the range of options. And in each case, there'll be both proprietary commercial solutions and open source solutions, and I'll cover those. So in stages, a simple task is synchronization. So you have data on one computer, like your website, and you want to push it to another one, like the FabAcademy server. So a really handy tool for that is called rsync. Rsync is very low level. What it does is it takes a whole system of files on one computer and synchronizes it with another computer. What's good about rsync is it's very, very efficient. And so this is commonly used for backups. Because if you change just a little bit on one computer, it doesn't copy everything over. It only copies over the little bit that changed. But it can do that very efficiently. So I use this to back up terabytes of data, to have a backup server where you take the production server and then you use rsync to replicate it. So rsync is low level, very efficient for moving lots of data. It goes only in one direction. Unison is like rsync, but it's symmetrical, because if both server and the client change, it can move information in both directions, but not efficiently as rsync. We won't be using those in the class, but those are good to know about. What we will be using in the class is version control. And version control is a key skill in what we're going to be doing. What version control does is it doesn't just maintain the current files, it maintains the history of the files. So right now, I'll take all of this. I'm going to explain what I just did more slowly, but this is the repository of the main class website. And online, this is what you see here, the class site. But what I'm showing here is the history of every change to every file in it. And in this case, I was doing some editing, and then during class, Fiore did some editing, and you'll see some branching and merging. And so what this maintains is not just the current files, but the history of the files. And so when you're working on a project, you might have a development version, you might be testing, you might be debugging, you could have versions in different languages. And so version control is one of the most important skills we're going to cover. In addition, version control is central to collaboration. So one of the earliest versions was called RCS, and that just manages the history of a file. CVS then manages a directory. These are all more historical. Subversion, Bazaar, Mercurial, all have histories. By far the most dominant version control system, and the one we're going to use, is called Git. So Git is has a somewhat steep learning curve. The way we're going to use it to start makes it easier. But Git does many, many different things. It manages the history of files. It manages multiple versions. So you can be working, well, let's go back to this example. Before class today, I was getting ready the random generator we use, and then I was doing some housekeeping. And then Fiore was doing some work on his version. And so at this point, there were two versions of the class site. And then just now, I merged them back together. And it took my changes and Fiore's changes and merged them back together. So Git manages collaboration with multiple people working on a project. It lets you manage servers. So all of this is going to be on the Fab Academy site, but you can be working on your own computer. And it lets you push changes from your server up to the class server. You'll be using it to work with other labs, both in your lab and between other labs. So it's a very, very powerful system. I'm going to run through many different layers of project management, and then I'm going to come back at the end of class and tell you much more about the class site. So GitHub, you've probably heard of. It's a web platform built on Git. It is a business that was then bought by Microsoft. We use GitLab in this class. GitLab is a business, but it's also an open source project. And it's a web platform that includes Git and many other things. And so if we go into Fab Cloud, which is our GitLab installation, this is the website for the class. Now I'm browsing it through a website, and I can use Git through the web interface as well as using it locally. And I'm going to come back and show you much more about that. So this is a link all about the class archive. And after I finish all the stages in project management, today I'll come back and talk more about the class archive. So you'll be using Git with GitLab to manage content in the class, develop it, and publish it. Dropbox does version control, but in sort of invisibly in the cloud. You run a client and you sync it to Dropbox as a service. OwnCloud is a version like Dropbox, but as an open source platform. Those are handy, but the version control is sort of implicit. It's not explicit. So you can think of Git with GitLab as being kind of like what those do, but it gives you much more fine-grained control over histories of versions and how you merge versions and do tasks like that. So you're going to use Git with GitLab to manage your content. So the next thing you need to do is build a website. So if we go back to last year, students, Anka will take. So here's Anka's website from last year. So how do you build a website? Well, you need to develop it. And one of the first things you need to do is be able to see your website as you're developing it. So this website is being served at FabAcadmy.org. That's a GitLab installation, and it's running a web server. And so it runs a powerful, popular web server called Nginx. And Apache is another powerful, popular one. So while you're developing, you could run those locally on your own computer to test your website before you publish it. Another thing you can do is, this is a simple web server a very simple web server you can install based on JavaScript, which we'll talk a lot about. And then browsers, depending on your permission, just let you open file systems. So if I go to this, in the browser, I'm actually looking at the file system on this computer. So if I go into Home, Ubuntu, Git, FabCloud, FabAcademy, we're in 2019, and then schedule. So here's the schedule online from the central server. Here I'm just viewing the schedule on my local computer, and the browser is viewing it. And so I can use that to test my website before I publish it to the server. Okay, so then you need to build the web page. And so W3C, hosted at MIT, standardizes the web. HTML is the format of web pages. Mozilla maintains a really nice set of documentation as references on the language. HTML5, we're going to see many times. These are extensions to the original web standards that let you do things like handle video and managing multiple processes. We'll see all of that later. And so one way to build web pages is just to learn raw HTML. And that's something I do a lot of. So here's a web page you see. I'm going to hit Control U. And Control U opens up the raw HTML. And so if we look at it, a div, for example, is a container, and this makes a margin. BR makes a line break. Ahref makes a web link. And so all of those make the page. And so learning those codes isn't hard to do. And so if you go to a reference like this, this explains all of those codes in the web page. And so to make a simple page like this, I'll typically just write the raw HTML because it's not many codes to learn and it's very easy and gives you good control. So you could make your web page by editing the raw HTML, but most of you likely won't do that because there's higher levels above that. So an increasingly popular alternative is called Markdown. And so what Markdown does is you just write plain text and you do things like asterisks or underlines or parentheses. There's no codes. It's just text you can read. But there's a standard for how it gets converted to HTML. So it doesn't do everything HTML can do, but it does the most popular things like lists and links and quotes. And so Markdown is a friendly, easy way to write a subset of HTML. So once you've written Markdown, then you need to convert it. So Strapdown is a project that lets you put a little JavaScript in a page, and it automatically converts your Markdown. Pandoc is a tool for converting it. Hugo and Jekyll are frameworks for making sites with Markdown. And one of the things you're going to use as a starting template is called mkdocs, which is a tool to build websites written in Markdown and convert them to HTML. And so when I get to your personal sites, we've set up starter pages that use we being Fiori has set up starter pages using Markdown with mkdocs that'll let you get started on your site, and you can use that, or you can later change it to another format. Gitbooks is a nice framework you can use for publishing things that are structured like books in Git. And then to do the editing, you need an editor. That sounds obvious, but there's many levels for that. So if we go back to the class site, I use an ancient editor called Vim, and it is very powerful. It's designed around, so right now I'm searching, I can write macros, I can edit, but my hands aren't moving from the keyboard. Just by typing on the keyboard, you can search, edit, rearrange, filter, and so it's a very powerful, just plain text editor. That's what I use to edit raw text files. These tools like Atom and Sublime and Gianni, these are open source editors, most cross-platform, that build more powerful visual interfaces. And so they have modes for when you're editing web pages versus computer code versus web code with a more powerful user interface. Then brackets and Eclipse are not just editors, they're whole development environment. So these are tools that let you edit something, but also do things like compile code and publish with it. Then come visual interfaces. So LibreOffice is a open source program like Microsoft Office, and one of its tools is LibreWriter. So this lets you do stuff with the graphical interface, but you can go back and forth. I'm going to save the project. So it lets you go back and forth between seeing the HTML source and seeing it as the original graphical code. So that lets you, if you want to do your development in a word processor environment, you can do it with that. Dreamweaver is a commercial version from Adobe that's very popular. Those are easier to use user interfaces to build web pages, but the HTML they produce tends to be uglier, that you don't actually see the HTML directly, you just see the user interface. So if you start using those, you really need to stay with them within the user interface. But those let you build web pages with interfaces very similar to word processors. Then JavaScript, we'll talk much more about later in the semester. It lets you build programs into web pages. And then there's a number of frameworks, and I'll cover more of this later, like Bootstrap and jQuery. These let you build all sorts of interfaces in your web pages. So dialogues and sliders and controls and interactivity in web pages is largely done with those. Then YAML is a language for describing workflows. And then CI/CD is an increasingly important concept around, let's say you're running a company with a big website. Rather than periodically just replacing the whole website, CI/CD lets you continuously update a running website with services, test it, debug it, publish it, measure it. And so the templates we have for you to make your sites use YAML and CI/CD to publish them. And so when I loop back at the end of this overview, I'm going to show you how you'll use a YAML workflow with Markdown to edit sites you'll publish through GitLab. And then in web standards, there's what's called CGI, which lets web pages run applications on the server. And PHP is a still popular alternative language. We don't support those for the class. Both of those have server configuration that's had a long history of security issues. And so the mix of things we use is easy to use on the server, but it's robust, that it doesn't expose vulnerabilities for hacking the server. So that's a series of steps from low-level HTML to Markdown to development environments, and all of those are options to build your websites. So then the next thing is, if we go back to, say, Anka's, each thing here is a web page. And so next week you're going to have a CAD assignment. Here's her web page describing what she did that week. And so each week, we don't want you just to simply show the final results. What we want you to do is log your work. And so follow along what worked, what didn't work, where did you trip up, what did you learn, what are your tips. You'll learn from these sites, and in turn, the sites you build will help teach other people. So each of these is a web page, and then this is a site made out of many web pages. And so you can do that one page at a time. Wikis are tools designed to make it easy to manage multiple pages on the site. So we don't run a wiki, well, we do on one part, but we don't run a conventional wiki on the Fab server for the class. But you can run a wiki locally and use that to generate your files, and you can push it to the site. Then beyond that, there are major site tools like WordPress, Drupal, and Moodle. These are content management systems to manage a site with all the files and all the content. We're not using those in the class for two reasons. One is they also have histories of vulnerabilities, but the other is they build particularly structured ways to work with the content. You're writing your sites in a way that lets them be all very different, that we're not giving you a specific, we're giving you a starting template, but the way we're building it, it's a platform where each of you can have a site that reflects you, that's different from everybody else, rather than having a standard content management system. So these are all options for content management, but largely you might choose to use a wiki, but most likely you'll just stay with these YAML workflows in GitLab, which again, I'll come back and show you. This next topic is largely historical. So to explain this, in the lab I run at MIT is this thing that's about $500,000 of Cisco equipment that runs a video conferencing server. And this is what we used to use for the class. And it speaks an industry standard for video conferencing called H323. And so we used to have to teach what are these standards and how you connect to it. The reason we don't do that anymore is WebRTC is one of the HTML5 standards to do real-time video and audio over the web. So that was a major step in web protocols. And then you're called into there's one of a few vendors, and the one we're using is BlueJeans. And what BlueJeans does is it runs in the cloud a version of what I showed you, the head end for video conferencing. And then it has native.
We can hear you at Dussault.
You can't hear me? Sorry, is anybody else having audio issues?
We hear you fine.
Fine in Ulu?
Fine here in Germany, Neil.
Okay. So it's fine in Germany and in Ulu?
We just got it.
Okay.
Thank you.
Yep. So Blue Jeans is one of a few vendors that runs a cloud MCU, multi-point control unit, and lets you connect with WebRTC clients. So that makes it much easier to run. So that's what we're using for the video conferencing. And then just two other links I have here that are good to know about. OBS Studio lets you turn a computer into a whole broadcasting solution. So one common question, for example, is how you share the video conference. The video conference we're now in allows a few hundred connections. And to understand that, it's easy to broadcast to 1 million people. It's much harder to do what we're doing because, as you saw in the last hour, everybody can see and talk to everybody. And so that's much more limited in capacity. But if you want to broadcast what we're doing, OBS lets you set up a studio that lets you broadcast to many people content. And if you want to record what we're doing, Simple Screen Recorder is my favorite tool that does audio and video recording of whatever is happening on a computer. So we're using WebRTC to talk to Blue Jeans for a video conference. Then just a few other notes on servers before we descend into the class site. What you're looking at is a computer running in the cloud. Kite VNC is a standard, open standard to use a computer remotely. X11 VNC lets you use the raw display driver. And then I'm running what's called no VNC, which turns VNC into JavaScript. So right now you see my desktop. It's running on a server in the cloud. That server is running VNC to share it with me, and then it's using no VNC. So I'm using a web page to control the desktop. So those let you manage computers interactively remotely, like I'm doing right now for the class. And then the server I'm using, I'm running this in AWS, which has EC2, which is a standard, which is their offering to run services in the cloud. And I do that so this class desktop I can use from all I need is a web browser, and I can run the class from it. Google, Ocean, DigitalOcean, Linode all offer cloud services like that. And Heroku is slightly different because it doesn't run a cloud server. It's designed to publish applications. So it does all the services to support an application. Now, as you work in the class, you're going to be managing projects. There's a number of tools that all look much like this. What these let you do is define a series of tasks and define what depends on what and track projects. GitLab, we'll come back and show you, has a lot of that built in. And so these are tools that if you're just working on an assignment, you do the assignment. But if there's multiple people and multiple tasks and deadlines and dependencies, you then need a tool like this to keep track of the progression in the project. And these are a number of options, but within it, there's a subset that GitLab lets you do that's very useful for project management. Now, I'm going to tell you at the beginning a few lessons about project management. And then at the very end, I'm going to come back and talk about the lessons again. All all of you are going to run out of time. You're guaranteed to run out of time in the class and be racing the schedule to finish your projects. And so there's a number of lessons that sound obvious but aren't for what leads to good project management. Triage is going to be a very important skill, that you're going to have ambitions that go way beyond what you might be able to accomplish. And so we'll keep coming back to triage to reduce. So triage is a term that comes back to when there's an accident and the first responders come. If people are stable, they don't need to respond. If they're in really bad shape, you can't help them. Triage is finding the people where help makes a difference. And so we'll keep talking about triage in your projects to figure out what's easy, what to give up on, and where it's worth help. A really important skill in the class is the difference between demand and supply side time management. Demand time management is you work on a task for the time that it takes. And that sounds obvious, but it fails. Because you have a series of tasks to finish your project, but if each task takes more time than you have available, you fall off the end. So supply side is a very different way of working. In supply side, you decide how much time you have available, and then you decide what you're going to do in that time, and you work to the schedule. So this week you have to build a website. You have 1 week to do it. Rather than just starting to work forward, step back now and make a schedule. Over the next 7 days, what has to happen on each day? And then each day you do as much as you can on that task, and then you stop. And you'll find to a surprising extent, you can work to the task defined by the schedule and meet the schedule. So it's very different working for the time that's demanded versus working to a schedule you set. A second important principle is serial development is where you do each task in turn, and a single task can fail and you get stuck on it. Parallel development is where you work on the tasks in parallel so one task doesn't block you. And so to do this week's assignment, you need to learn about version control. You need to learn about web development. You need to build each of these skills. And rather than doing them in order, you can run those as parallel streams, working on a bit of time on each one, so no single task blocks your progress. Another really important skill is what's called spiral development. And I'll say this many times throughout the semester. So where this dates back to is the U.S. Department of Defense had a bad habit of spending 10 years and $1 billion to develop something that didn't work. They had some very notable failures of huge projects that failed. And what they were doing was they would start from the beginning of the conception of the project and work to the end on the project, which again sounds obvious. What spiral development does is, let's take the example of the website. Here you are today, at the end of a week, you have the website. A spiral is a complete loop that ends with something working. And so a first spiral for this week is use the web template we gave you. A second spiral would be to edit a little bit on the template but republish it. A third spiral would be to put some new content on the site. A fourth spiral would be to change the template. And then another spiral would be to eliminate the template and replace it with another web protocol. And so if we go back to some of the final projects we heard, the composting system, the first version could have no compost and just have the container. A second version would still not have compost, but would have sensors. Then a third version would introduce the materials in it, but not compost it. A first version would actually make compost, but not control it. And then a fifth version would actually make compost and control it. But the idea is each spiral goes back to a complete system, and then you add capability to it. And by looping, it's a very different way of working where you keep getting a chance to refine the development. Something that's going to lead to great frustration is in, for example, the electronics production week, you're going to all make one of these. This is a programmer. It's a circuit that lets you put programs in circuits. So you're all going to make one of those, and then you'll have a problem if it doesn't work. So you build your system and it doesn't work. So you're going to be doing a lot of debugging. And there's two broad strategies to debug. Top down is you take a system with a problem and you start removing elements from it until you find the problem. Bottom up is you start with nothing and you start adding parts to the system. So top down would be this is broken and you start taking things apart until you find the problem. Bottom up is you don't make the whole thing in one go. You start adding a few parts at a time and test those parts. And so to really be able to do that, it's very helpful, instead of making one big project, to make your project modular. And we'll keep coming back to that, to build a big project in a number of small modules. So let's say you wanted to make, we had the example of the wearable clothing with jewelry. Rather than making it as a single monolithic garment, you could have one system that's a display, one that's a controller, one that communicates, one that's an interconnect. And each of those you can develop separately and then put them together to make the system. A really big one for the class is every week you're going to run out of time. And so if you wait to document your work until the end of the week, you won't have enough time. So if you go back to Anka's site, what you'll see is she's documenting as she's working. She's making notes, logging her progress. And so at the end of the week, she's done. And so don't do the week's assignment and then document it. Get in the habit of documenting as you work. In the same way, if we go back to Anka's final project, rather than waiting until the very end, what you'll see is here's her first sketches, here's her prototyping, then here's the things she's adding. And throughout the whole class, each week she's adding a little bit more to the final project documentation. And so by the time we get to the end of the year, most of it's done and she just has to finish a little bit. So learn how to document as you work, not work and then document. A good resource for all of these, this is a book I'm very fond of. This is called The Mythical Man Month, and it's principles on project management. He ran the IBM project that developed the first really successful mainframe computer. And it's a lot of lessons of what goes wrong in project management. Like, one of the principles from this is, a pregnancy takes 9 months no matter how many women you assign to it. Some tasks have a set amount of time they require, and you have to design around that time rather than the effort you put into it. There's a bunch of good insights like that into project management. So each of these sound obvious, but each of these points has been the subject of major failures in project management. And they're all lessons that we'll keep coming back to. You'll hear me over and over talk about things like triage and modularity and spiral development as good principles in project development. Okay, now let's loop back into more detail on your class sites. So this is a link to a page of notes about the class archive. Here is the main Git site, very important open source project. Git has its own tutorials. It has really good tutorials. There's a book, and if you just search for Git tutorial, you'll find lots and lots and lots of tutorials. The first part of your assignment is work through a Git tutorial. So the reason that's not obvious is Git isn't obvious. Git has a series of principles, and I've got a bunch of them down here. I'm going to skim through these that include things like commits, merging, branching, and none of this will make sense until you do a tutorial. So you can't learn Git just by clicking and dragging. It's beautifully documented, and you need to work through one of these tutorials to understand these basic principles of, again, branching, versioning, merging, pushing, pulling. It just won't make sense until you do the tutorial. So read a Git tutorial. Now, there's multiple versions of Git. You can get Git directly from Git, but you can get it all sorts of other ways. So you can use Git from a graphical interface, and these are a number of them. And so as a beginner, the graphical interface is friendly and easy. GitLab includes one of the graphical interfaces that I'll show you. But you can also use Git from a terminal. And the more expert you get in Git, the more you'll use a terminal rather than a graphical interface, because it's much faster and more efficient. So almost all the Git I do is using a terminal for commands. So on GitLab, here I am on GitLab. Here's the class. Here's the labs. And so we'll go into Charlotte. Here's Charlotte students. Each student, thanks to Fiori, has a project. So now this is William Knight's project in Git. You can edit your website through GitLab. You can use this user interface, and I'll do an example in a few minutes and edit a file here. Or you can edit locally. And so to start, you're likely to edit on the server. But then as you progress, you should move to being able to do it locally. And so in Windows, the easiest way to do it is Windows has a Linux subsystem. And if you turn on the Linux subsystem, you can then get Git. In Linux, which I primarily use, it's built into the package managers. And so I use Ubuntu in the Xubuntu distribution. And here's a little script I run to set up a server. And so you then get Git through Linux. And a surprisingly neat way to do it is Android, not iOS, but Android is based on Linux, and Termex exposes it. And this lets you use Git from an Android device. And so, in fact, on my phone or tablet, I use Git to manage all of the content. All of my personal files are in Git, and I just use Git to synchronize it with my portable device. So now we get to your class site. So GitLab is going to do many things for us in the class. It manages repositories. So a repository is a single Git project. So if we go to Charlotte, each student in Charlotte has a project, which is a Git repository. Then each lab is a group of projects. And then finally, the whole Fab Academy is a group of groups of projects. GitLab also has issue trackers, and they're how we're going to communicate. It also has workflows for publishing. It has wikis built in. It has milestones to track tasks. And it has what are called Kanban boards to manage workflows through tasks. And for today, I'm going to focus on Git and on the issue trackers. At Monday's recitation, Fiore will fill in much more about everything else running on the server. So you need to build your site. So once again, Git is a distributed version control system, which means it manages the history of your work. It merges changes with multiple versions. So you can have a version on the server, a version on a laptop, a version on your phone, and it merges the changes. It lets you collaborate with somebody else and share work between them. And it lets you manage a remote server. So those are all the things Git's going to do with you. So let me first show doing it on the server, then show doing it locally. Then I'm going to talk about some common Git mistakes, and then I'll talk about important Git commands. So if we go back to labs, Charlotte, William Knight as a test case, we go into Fab Academy 2019, Charlotte, Latin, William Knight. So here's Will Knight. Let's see. Will, are you there in Charlotte? Here's William Knight's page online. Here it is in GitLab. This is a Git project. So it's a repository. There's a version on the server, and you can also use it locally, which I'll show you. So in this repository, here you can see the history of Fiore first set it up, and then Will got a little bit ahead, which is good, and started editing it. These files, the README is just instructions for you. GitLab CI YML, all of that is a YAML file. And what that does is that does the work of publishing the site. So here's the site published. This tells the server how to publish the site, and you won't have to edit that. This is a little template to build the site. And then these are the requirements to publish it. And so all of that is a little workflow that does all of that. Let's see, there was a note of another Charlotte student that's put some pictures in. So here, this was Katie. So if we go to, yeah, Katie has a picture on her site. So here's the initial index page on the website. And so here it is published. And so I can edit it right here. So if I just start editing here, I opened an editor on the server, and I just made a little edit to Katie's site. And then it takes a minute or two. And in a minute or two, it has to go through that workflow, and it'll get published, and it'll just these simple markdown codes. And that's all you need to edit it. So that's to start how you build your site. Now, as you progress, though, you're going to want to have your own copy. So let's go back to, here's the class schedule. Here I am in a terminal on the class site. So I'm going to do this now from a command line. I'm going to pull, I'm going to edit the schedule. So right now I'm editing on the local computer. So I just said, hello, class. Here's the status of what I just did. I'm going to commit it. I'm going to commit it. This is a class demo, and I'm going to push it. So what just happened is I got a copy from the server. I pulled it down to this computer. I edited it on this computer, but this computer could be a computer in your lab. It could be a laptop. It could be a phone. It could be anything that can run Git. And then I just sent it back to the server. And so again, it takes, okay, so here's the hello class. Now here it is on the Fab Academy site. Now, if we go to the server, 2019 site, here's the class site on the server, and here's the history, and here you can see, here's the edit I just made. The server remembered the edit I just made. But now if I come locally, this is a history viewer I'm running on this local computer. And so here's the change I just made. And it shows me I took the schedule and I made that change to the schedule. And so I used Git locally to make an edit and pushed it onto the server. Now, if I look at this computer, here's the whole file system on the computer. If you look on the server, here's the class website, and here are all its files. And then if I look locally, here are all the files on this computer. But the difference is there's a little hidden file called .git. And usually these dot files are hidden. But in that .git is the whole history. And so this is initially a little confusing. You're used to seeing files in a file system. But a Git repository also has not just the files, but the history of all the files. And so I could go back to, if I take the class repository, I could reset to this point. And so now all the files jump back to that point in history. Or I could jump forward to the present. So I can move around through the history. I can see what versions of files, I can change files. It's a snapshot of the whole history of the project as well as the present. So to do what I just did with the repository locally, I had to have a key. And so each of you has a GitLab account, and in your GitLab account are settings. And one of the settings is a key. And so one of the things you need to do to work locally is you can use GitLab to generate a key. And so when I pulled the repository, GitLab used my key to authenticate, to tell it who I was. And so initially, as a beginner, you'll just edit on the site through the web interface. But then by putting a key on the server and having a copy locally, that's how you authenticate and work locally. And very quickly, you'll want to be able to do that so you can use local editors and work on your local computer. This again is a lot to learn in a first sitting. It's going to take a few weeks if you're a beginner to get used to Git, but this is going to be one of the most valuable skills in the class you'll find. Now there's some common mistakes you're going to make. So here's a summary of mistakes that you're going to run into. One is when you're ready to have your repository on your local computer, and also the labs have repositories and you're going to use those for group projects. One issue is you need to set the permissions on the file with your key. Otherwise Git will complain and it'll tell you if there's a problem with that. A really important thing is Git status checks the status. Right now there's nothing to do. Here, I'll edit the schedule and I'll delete the little change I made. If we do Git status, now it knows that needs to be changed. I'll add that to be committed. I'll commit it with a message, and I'll push it. Check what you're going to commit before you do it, because a beginner mistake is you accidentally put your laundry list or a whole bunch of other files in your repository, and you commit a bunch of stuff that isn't supposed to be there. And Git makes it hard to change history. So if I go back into this, if I made a mistake somewhere in the history of my repository, it's intentionally very hard to go back and change the history because it maintains it. So check what you commit. If you try to push your work before you've pulled it, Git will complain. And so these concepts of pulling and merging, you need to pull, merge, then push. Once you push your work, you need to refresh the page. The page won't automatically refresh. You're going to link to pictures. When you link to pictures, if you look at the page, the picture links need to be relative to where the picture is. So this link is to images / JPEG. The link isn't to the full path on the server, because that would break if you move the files. So you link locally, and all of this will make sense. And then we expect each of you to generate roughly megabytes per week, so that each lab generates gigabytes by the end of the semester, so that the whole class generates about a terabyte. Got that? So megabytes per person per week is gigabytes per lab, which is terabytes per class. But a single picture can be, with a really big camera, could be 100 megabytes. So a really important skill is to check sizes. And so if du minus s, so du is a little utility to check sizes. And right now these are small, but it's a little utility that check the sizes of your files. And one of the most common mistakes is you check in a bunch of uncompressed pictures. If you check in uncompressed pictures right from your camera, they take a lot of space on the server, but it also means your web page is going to take a long time to load. So for web resolution, you want to compress your picture and reduce the resolution to no more than the screen size to view it. So you can do that with the picture editor. I'll show that next week. But ImageMagick is a really handy utility, open source, cross-platform, to convert almost anything to do with images to almost anything with images. And so here's a little cheat sheet. So what this will do is it'll take a directory of pictures. It'll fix the size of them, and it'll fix the quality of them to compress them to put on the web. And so a web resolution picture can be, say, tens of kilobytes or maybe 100 kilobytes for a big one, whereas the raw camera image might be tens of megabytes. And so this little step can reduce the image size by like 1,000 to 1. And again, that's your space on your computer. That's our space on the server, but it's also for the person viewing your page, so they don't have to wait for a big picture to load through a slow connection. So it's very important that you compress your images to not take more space than they need. And it's really true for videos. For really big videos, they shouldn't go in the repository. They should go on a video site. But FFmpeg does for video what ImageMagick does for pictures. And so here's, for example, a sequence where you pick the bit rate that you want the video to be at. And so if you take a video of your project to document it, the video might be hundreds of megabytes or a gigabyte. But if you do this, it'll reduce it down to a few megabytes. So some of you are guaranteed to make these mistakes. Check your sizes, compress images, and compress videos. And initially, we'll look after you, and we're going to highlight when you get that wrong. This makes, again, your life easier to keep your files manageable on your computer. It makes our life easier because it keeps it manageable on the server, but it makes your viewers' life easy because they don't need to download big files to see your content. Okay. So when you get set up to use Git locally, and once again, at the beginning, you're not going to do that. At the beginning, unless you're already an expert, you'll just use the GitLab interface and edit here, but you'll quickly grow beyond that. So to edit locally, there's one file that you have to set up with your name and your email address, so Git knows who you are. Then there's one file you have to set up that tells Git how to find the server. And Fiori, again, in the recitation is going to recap all of this. And then there's some other files you can use if you want Git to ignore things. So now finally we come to the commands. Everything you do in Git can be done from the server. It can be done with a graphical interface like these, or it can be done from a terminal, but they're all the same underlying command. And once again, experts tend to just type the commands directly because it's more efficient than clicking and dragging. So if you ask for help, Git will give you help. So Git helpful. So it has lots of good help built in. Config tells you how it's currently set up. While you're getting it set up, you need to use that. You can use the config command to edit the files I showed you without actually editing them directly, to tell it who you are. Git init. So you have a repository for the class, but one of the things I encourage you to do is practice. So if I go to this computer, I'll just go on the desktop. I'll make a directory sample, and I'll go into the sample, and I'll edit test. So right now, this is just a file. And so if I ask Git, it says this isn't Git. But if I say Git init, now it's a Git repository. So now I can say Git status, and I have this file. So I'm going to add it, Git commit first bit. If I look at this, I'm going to have just a single entry. I have a repository with a single thing that happened in it. But now I can start doing everything I showed you. So one of the things you can do is make your own practice repository to try out all these commands before you start doing it on the class ones. You clone to pull a repository. So if I go git clone fabcloud academy / FabAcademy / 2019 / site. So what I just did right now is I took the class site, which from there on the server, and I just replicated the repository on this local computer. So cloning is how you copy it. Then once you've cloned it, so if I go into the site, git pull will pull updates from the server. Push is how you send your work back to the server. Add is where you tell it what files to track. Commit is like taking a picture. That's where you make a snapshot of a current state of the files. Log will show you the history. If you want to remove or move a file, you need to tell Git because it's tracking it. So those are commands to do it. If you make a mess up and everything goes off the rails, you can reset to go back to the last good commit. If I do some work and you do some work, we need to merge our work together. And so if it's a simple merge, Git will do it automatically. Git merge will tell you how to do it. If you and I change the same file in the same place, there'll be a merge conflict, and it'll tell us you have a conflict, and you can use that to fix it. Then more advanced is you can have multiple branches. You can have your project in versions in different languages, for example. And so branches let you jump between different versions of the same project. And then submodules and subtrees are more advanced things to use Git within Git. And then it's got a thing called LFS, which is Git for managing extra large files. In Git, each file exists in two places, the current version and the history version. For really big files, you don't want to do that, and so LFS is to do that. So I don't expect you to remember remotely what I just did, but those are the kinds of commands in Git. You'll start learning about them as you go through the tutorial. Now, a final very important thing in GitLab is, let's go back to 2019. We don't use mailing lists in the class. We use issue trackers. And so I'm going to go in the class site, and I'm going to, now, in the class site, if you see this global setting, I'm going to change it to watched. Watch means you get an email message anytime anything happens. And so you should watch the projects you're in. So you should set that to watch. So now what I'm going to do is I'm going to start a couple issues. I'm going to make a new issue is final here's an issue. You're all part of this project. And so there was the project in Dubai, in UAE on capillary agriculture. What you can use this issue to talk about projects, raise projects, collaborate on projects. And every time you post here, it'll go to everybody watching the issue, which means you shouldn't do this lightly because you're going to broadcast to the whole class. But conversely, you can use this to talk to the whole class. Now, in addition, each of your labs, to go back to the labs, each lab has a project. And so you can use the issue tracker in the lab project just to talk within your lab. So what's nice about these issue trackers is they end up sending you email messages, but you don't answer email. You don't get email storms and long lines of messages. You end up with these issues, and then you answer through the issues. So I'm going to add a second important assignment for this week, which is new issue, and the issue is going to be sign agreements. So one of the things we want you to do this week is, this is on the class site is, the documents are here. So labs, instructors, students, copy agreements to your repo, add your name, and commit. So what that's about is almost all of you do amazing work, but a lot of effort goes into this. And historically, there have been some issues with some people doing things like not working safely or misrepresenting their work or not cleaning up the lab. And so what we like to do is each lab has a responsibility, each instructor has a responsibility, and each student has responsibilities, and the Fab Academy has responsibilities. And so as part of this week's assignment, we want each of you to copy the respective file, put it in your directory, and sign it. And it just shows that you've reviewed and you're committing to what we all expect. So you expect a lot from your lab instructor in the Fab Academy. And in turn, this is what we expect from you to hold up your part of making the class work reliably. Okay? So that's a lot, and it'll take you a while to master this. So if you go back to spiral development, at a minimum this week, edit your template site, start your personal site, and we saw some examples already. Let's see, Pavel, are you unmuting?
Pardon?
Yeah.
Yes, I am.
Do you want to say something, Pavel?
Sorry?
You've unmuted. You're interrupting. Do you want to say something?
No.
Okay. Can you mute?
Yes, I can hear you.
Okay. No, I want you to mute. I'm going to mute you. Okay. So if we took the example of Polytech, so just Pavel made a first start of about me. Here's a little bit about him, and then a little bit about initial project plans. And so for this week, we want you to build your site, describe yourself, start describing your final project. And then if you're overwhelmed by all of this, just use the template. But as you progress, or if you're more advanced, what you should learn how to do is copy the repository on your computer. And then in the end, we don't want all of your sites to look the same. We want you to personalize your site and start learning how to customize the site and make it more expressive. So then Monday, Fiore will spend an hour just on GitLab and version control. Next week, we'll talk through, remember, each week is a week-long cycle. So after I introduce the topic, it may sound like it makes sense, but then you're confused when you start working. You'll go off and work for a week, and it only really starts to make sense when we review it after the week. And so next week, we'll review your experience with Git and version control and go over tips and tricks and problems. And each week people use different tools. So we'll see who used what kind of site tools, who used what kind of Git tools. But a week from now, you should be comfortable with version control. And then next week is the first real working class. So that's where I'm going to cover CAD tools. And next week, your assignment is going to be to model and render your final project. And so you need to have your site ready to do the assignment a week from now to do a modeling of your final project. And then from there, we'll start in the week after that on fabrication processes. So any questions or comments? Okay.
Hello.
Yep.
Hi, Neil, I have a question regarding one of the project management principles that you talked about, serial versus parallel development.
Yep.
So I'm a continuing student. So I heard this last year also, and I tried to use it last year and also in my life to do several other things. So when you are doing parallel management of multiple things, is there some kind of a guidance on how many things you should have in parallel? Or that's my question. Is there a guidance, or how do you decide that?
Yeah. So there isn't a single answer, but good guidance is computer operating systems do this, and there's some good analogies. So there's a stack depth in a computer operating system. And so the number of processes is based on the depth of the stack it can store. And there's a thing called thrashing, where if there's too many processes and it switches them too quickly, it never gets anything done because it's just thrashing between the processes. If there's too few processes, one process can block any of them. And so there isn't with that mental picture, you need to learn your stack depth. And so for me, it might be 5. I might be able to do 5 processes that I can keep track of at any one time, but you need to learn your own stack depth, as a personal design principle. But to apply that to this week, one of the things you should start doing is learning HTML. One is to start learning GitLab. One is to start learning Git. One is to start learning cloning. And rather than doing those in order, go back and forth between them and spend some time on each of them because they'll each talk to each other. Yeah. A final meta note, which is this class is taking a whole cloud of information and we're feeding it through a linear path, the video conference in your eyes and ears. But in your brain, it's going to reform into a cloud. And so sort of don't worry, be happy. Any one moment, any one part of this is going to be confusing, but sort of let it flow in and let it reform in your head. And so each week you'll have successes, but frustrations as it's confusing. And each week, all of these things will form up tighter and tighter as we progress. Okay, so we're up to 12. With that, we're now underway. This is really, this is like learning to read before reading Shakespeare. This is a real just beginning week. But version control is one of the most powerful skills you'll take away from the class. And then next week, we'll really be underway with the real Fab Academy content. So do join Fiori Monday for more on version control, and then we'll pick up next week. Okay. See you all in a week. Bye-bye.
Bye.
Bye. Bye.
Recording has stopped.
Hello. Hello.
Hi.
Hi.